In the last video, we showed you how to set up the Brewster's angle experiment. In this video, we're going to show you the calibration procedure and the data collection process necessary. So to start off, first thing you're going to want to do is on each of your light sensors, press the middle green button that looks like an incandescent light bulb to set the range to 0 to 100. After that, and assuming you have followed all the steps in the previous video, we can start with the calibration process. So to start this, we're going to use the monitor button, and we're going to use the polarizer. We're going to adjust this so that both the reference light and the light sensor on the arm are reading below 95%. And we're just going to rotate this slowly. You can see that one adjusting. Jumping around. Okay, right about there is close enough. So we'll go ahead and stop that. Next thing we're going to do is zero the rotary motion sensor angle. Now, the first thing I've done in this particular case is go into hardware setup and then click on the gear icon next to the rotary motion sensor and make sure the box that says 0 sensor measurement at start is unchecked. We want this unchecked so that way, if in the event that you do accidentally stop recording during the data collection, you don't need to do this process all over again. It'll remember the last location that it would start at, so you can start your run again and continue with your data collection. So we'll go and do that. Now we'll go ahead and remove the D-lens. Just going to remove the entire assembly and set it on the side here. And we'll have laser beam on. And we're going to use monitor again. What we're going to do is we are going to adjust the arm position until we see a relative maximum or minimum reading in the light sensor arm box. Okay. This part can take a little bit, so be patient. About right there. Seems to be like the relative max. And if we physically look, looks just about right. We'll go ahead and stop. And then we'll go back into hardware setup. Now that we've done that, we will click 0 sensor now. Now this is the starting position for all the data collection going forward. Now replace the D-lens. Now if you have the latest model, your D-lens is magnetic, so it won't slide and move around. So placing it back on the table for the experiment will be much easier. And getting it lined up just as you did before. Okay. All right. Now for this next step, we're going to go into the data collection page. So what we're going to do now is that we've got this recording. We're going to adjust our lens to the 85-degree mark using this indicator here and using the smaller indicator on the Brewster accessory. I'm going to set this to roughly 85 degrees. And now we're going to rotate the arm through to that position. Oops, helps to set it correctly. I had it set to 85, or sorry, 75. There we go. Now we can try again. And so we're trying to find the position where the laser light passes through the slit and creates a relative maximum. Okay, so we're just trying to find that maximum spot. Oh, 1920, okay. All right, looks like we're finally settling on a decent value. So once we've found that relative peak, we'll take our analyzing polarizer. Now, keep in mind the orientation of the transmission lines here. Now, before we keep a point, we're going to place this on the arm, make sure it is perfectly flat and parallel. Then we're going to turn off the lights. So we still have the light from screens that are in here. In an ideal situation, you will have all lights off. And then we will keep this sample. And then we will take the analyzing polarizer one more time. We'll take it and we will rotate it 90 degrees. So we're analyzing both sets of the waveform. Turn the lights off. And hit keep sample. Then we go and turn the lights back on. And then we rotate the lens another 5 degrees and repeat the process. Remove the analyzing polarizer. And once again, adjust the arm. And right now, as you can see, we're dipping below our reference light sensor is getting kind of low, so let's try adjusting the polarizer a little bit in either direction to see if we can boost it. There we go. And the reason we can do this is because we're just taking the ratio of the reference light sensor to the measured. So we're always going to get a normalized output. There, okay. Right there is fine. And now let's continue adjusting the arm until we're at the relative peak spot, which I think I might have just found. That looks about right. Okay. So now we've done that. Let's go ahead and place our analyzing polarizer back on and turn off the light. Keep the sample. Whoops, I accidentally hit stop. Keep that sample. And then we'll take the analyzing polarizer off and rotate it 90 degrees. And same thing, keep the sample. Now we'll turn the lights back on. And we'll rotate the disc to 75 degrees. And we'll once again adjust the angle on the arm till we're reading a relative max. Right there. Okay. And we'll hit keep sample. Whoops. Forgot. Before we do that, make sure you keep the order in which you're doing the transmission axes consistent. So when you're inputting the data from this table over here, you're not mixing anything up. So we'll keep that sample and we'll rotate this again. Like I said, and keep that sample. Okay. Now go through and do this in increments of 5 degrees, at least all the way down to about 30 degrees, just so you have enough points on both sides of the angle that gives us the refractive index or the Brewster's angle. So we'll go and stop here. And then with these values, you will enter them over here in this table. $8.93, whoops. Polarized, parallel. Then we'll do the next run. Whoops, 70. Then enter the corresponding values, 4.5, 84.8, 6.1, 80.8. So what it's doing is it's taking the ratio of each set and normalizing it for each of those. And so on the next page, you would have a graph. Now with more data points, this would look a lot more like two sets of sinusoidal curves which it's on the way to becoming. We have one that's increasing to its peak, and then it'll bottom. And then we have one that's decreasing to its minimum, and then on its way back up. And so the point where this graph's maximum and this graph's minimum are is the Brewster's angle, because they will align right on top of each other over that particular angle. And that's how you do the data collection for Brewster's angle experiment.